Hey everybody, welcome back to another video. In this one, I want to talk about inflammation and more importantly, neuroinflammation and how neuroinflammation can lead to various cognitive symptoms like memory loss or brain fog or just feeling cognitively slow, those kind of things. So my name is Dr. Matthew Shem. I'm the owner of Peak Brain Performance Centers here in beautiful Colorado Springs. And the first thing I want to talk about is how we have two different types of cells in our brain. Number one being the ones that you've probably heard of before, that being neurons. And those are kind of like the sexy cells in the brain that everybody's heard of. But the reality is that only 10% of the cells in our brain are actually neurons. And so the other cells, glial cells, actually make up 90% of the overall cell volume in the brain. And you probably haven't heard of those before. So let's discuss more about what those really are. The first ones that we have are Schwann cells and oligodendrocytes, which aren't necessarily as important in regards to the lecture that we are talking about today. But basically what those do is they coat what's called myelin, which is a protein that they wrap around the axons of these neurons to basically increase the conduction speed of the neurons so that they can send their signals just a little bit faster. And these areas of myelin can become vulnerable whenever you have demyelinating conditions like MS, where now these myelin sheaths get attacked and it leads to a slowing of this nerve signal, or this action potential really, that goes from one neuron to the next. But more importantly, the ones that we want to talk about today are microglial cells and astrocytes. So first up is astrocytes. And astrocytes are really important because they regulate the blood-brain barrier. Blood-brain barrier being kind of like a Great Wall of China that's around your brain that's kind of protecting things from getting in and out. And they're also really, really important in regards to supporting neurons and helping neurons do the things that they need to do. So for example, they help remove neurotransmitters, they help drive blood flow and oxygen to neurons. So it's kind of just fueling these neurons and giving them the appropriate nutrients and stuff that they need to be able to do their job. The next ones that we're going to talk about is called microglial cells. And microglial cells are really important because they're kind of like these little scavengers in your brain that kind of just roam around and traverse the grounds to make sure that we don't have any debris and all this kind of trash that is building up in our brain. And whenever that happens, whenever it's roaming around and it sees some debris, it eats it up and it gets rid of it and it disposes of it. So similar to how you may prune a tree and get rid of all the dead branches to make sure that that thing continues to grow. Same kind of thing here. And if you actually look at the microglial cell, it has all these like almost feet-like projections off of it. And that's to give it the ability to kind of traverse the grounds and move around and be mobile so it can go and eat up this dead tissue. So in regards to neuroinflammation, what is the actual cause of neuroinflammation? How do I get inflammation in my brain? And one of the more interesting things that I think of, one of the more interesting ways that I talk about is, for one, we have something called the vagus nerve. And the vagus nerve is really important because it comes from our brainstem and it goes down and innervates all of our abdominal cavity. And so for one, you have a connection between the brain and our liver. And that connection is made through the vagus nerve. And whenever you have high levels of CRP, which is a liver marker and an inflammatory marker that you'll see on your lab panel, what happens is that CRP can then attach to the vagus and travel up to the brain and turn on inflammation in the brain. Also, when you have inflammation in the gut, now that, again, that inflammation travels up the vagus nerve and into the brain and turns on inflammation in the brain. Another one that we're going to talk about is, like we talked about before, this astrocyte kind of regulates the blood-brain barrier. And how it can lead to inflammatory signals getting into the brain is, for one, these inflammatory signals bind to the endothelial receptors on the blood-brain barrier, and those endothelial receptors activate the astrocyte, and the astrocyte's response is to turn on inflammatory responses in the brain. And another thing, too, to think about is that we have this blood-brain barrier that wraps around our brain, but this blood-brain barrier is not perfect, and it's not sealed off in 360 degrees to make sure that nothing, no foreign invader can get in and anything like that. So just like how it would be with, let's say, an old wall that you have built up, there's going to be cracks and things in that wall. And so similar to the blood-brain barrier, where it's not 100% sealed off, and there are permeable areas which can lead to inflammation getting into the brain. And so this is a cool video that I wanted to show you, but for some reason it won't play while I'm also recording. So if you look in the corner here, I have a link to the video and also link it down below. But what basically you're going to see in this video is you'll see a neuron sending a signal to another neuron, and you'll see that in the first aspect of the video, there's a normal nerve conduction. And so what you'll see is that this neuron A is going to send its signal to neuron B, and it's going to go pretty fast. Now, then they're going to switch to an inflammatory situation where you have a lot of inflammation in the brain itself. And you'll see that the nerve conduction of these nerves from getting signals from neuron A to neuron B is a lot slower than in the normal condition. And so you can kind of put two and two together and see how if I have this inflammation in my brain and it's going to be slowing down the conduction from neurons being able to talk to one another, you can see how that may lead to something like slowed cognitive activity or brain fog, or maybe you feel forgetful. So talking about the different types of symptoms that we're going to see is we kind of classify these different inflammatory aspects into mild, moderate, and severe. And mild being just noticing a little bit of brain fog, noticeable variations in your mental speed, reduced brain endurance, brain fatigue after exposure to specific chemicals, scents, or pollutants. So let's say maybe that you are around somebody and they have this strong perfume on, and then you notice that after that, it kind of triggers you and makes you feel a little less cognitively sharp. But then as you move away from that person and you progress through your everyday and you're not in that environment, then things kind of normalize again. Another thing is brain fog or brain fatigue after exposure to certain food proteins. So for example, let's say that you ingest some gluten, which is a very inflammatory food, or dairy. These can lead to these inflammatory cytokines mediating in your brain. And so you'll notice that you'll start feeling a little bit of brain fatigue or brain fog or just lack of mental clarity. And then how you'll know that you're kind of in this mild stage is maybe you then take some sort of anti-inflammatory and you feel fine. The next category we have here is moderate symptoms. And this one, things getting a little bit worse. Now you start noticing that you feel depressed. Your ability to concentrate, especially for long periods of time, is very difficult. You're always kind of sleepy. You have an increased demand for sleep, as in like you can get 8 hours of sleep and you still feel tired. Lethargy and fatigue, a lack of motivation, a lack of appetite, malaise, and an inability to be physically active, just kind of like a depressed overall feeling of no drive to want to do anything. And then whenever things get really severe, you can start seeing things like coma and seizures, which typically aren't going to be presenting because you're somebody like myself. But just to get it out there. And then another thing I want to talk about is in regards to the microglia. When you have all this inflammation in your brain, our brains don't really have a really good antioxidant system, meaning a system that can go and modulate and dampen down this inflammatory aspect on its own. And really, these microglia that we talked about before are responsible for making antioxidants in the brain. However, under these chronic inflammatory conditions, your microglia become depleted. And so you can see how this is kind of a perpetuous cycle in the fact that you get all of this inflammation in your brain and you need your microglia to then go make antioxidants. But the longer that this inflammation is in your brain, the more that these microglia become depleted. And why this can be problematic is unlike like skin cells or your liver cells or anything like that, if you lose some skin cells, like let's say you fall down and you skin your hand, you'll notice that eventually that skin's going to grow back, right? And you're not going to have that little cut forever, this little rash on your hand forever. The brain is not the same. And the fact that these microglia, they don't have a life cycle where you're going to grow more, right? And so whenever you lose them, you'll lose them. And so this is really important when it comes to figuring out if you have this neuroinflammation and then monitoring it and managing it so that it doesn't get worse, and then you just go down this perpetual cycle where you're going from doctor to doctor, you're trying to figure things out and nobody's helping you, and then you just continually getting worse. So in the next video, we're going to talk about what happens when these microglia become primed and how this can be really, really dangerous, in the fact that if you see on the left, that's one of those microglial cells. And like we talked about before, it has all these little legs on it, which allows it to kind of be mobile and go around your brain and look for this debris. But what happens is whenever these microglia become primed, is you can see how they kind of lose their legs, right? They're more blunted, and that makes it to where they have difficulty getting around. And this makes it to where now they can't survey the territory and go and eat up all the dead debris. And so we're going to talk about that in the next class, and how whenever you do have these microglia that become primed, you're going to see more symptoms like small triggers. Like, let's say I eat some gluten, and then I'm just down for the count for the next day. I'm just have to lay in bed. And these are very, very severe types of conditions that need to be managed. So we're going to talk about in the next video. I hope you enjoyed that one. If you have any questions for me, feel free to email my office or give my office a call. Other than that, I look forward to seeing you in the next one.